Okay, let's start now. Okay, I think we stop at integration by parts. Okay, so for the integration by parts, okay, when you are given the questions on integrations, normally you start with substitutions. If you fail to do substitution methods, okay, if you fail to integrate by using substitution method, then you move on to the other methods um, integration by parts. Okay, but please try substitution method, okay, before you start other methods, because substitution method is the easiest, okay, methods for you to try. Okay, okay, let's look at this integration by parts. Okay, integration by parts is the method that we have learned during the secondary school. So I don't want to discuss too much on this, but let's look at some example before we move on to the next method. Okay, okay, use integration method, integration by parts to evaluate integration x cos x dx. Okay, so for these integrations, integration of u dv, okay, integration by parts is given by uv minus integration of v du. So before that, um, you have to choose which variable that you want to denote for u and which variable is for dv. Okay, so if you choose u for x, if you choose u for x, then your dv will be cos x dx. Okay, for the other choice is if you choose u equal to cos x, then your dv will be what? Will be x dx. So these two are the choices for you in order to solve by using integration by parts. Okay. Yeah. Okay. Let's try with the first choice, which is u equal to x and dv equal to cos x dx. Okay. So if you choose u equal to x and dv is equal to cos x dx, your u is already this one. But to get v, you have to integrate this dv. So what will be the answer if you integrate these integrations? Okay, it will be sine x. Okay, so your u is x, your v will be sine x. Okay, and then what? And then uv is already known here. For the integration of v du, is it easy for you to solve this new integral? Okay, integration of v here is sine x. Okay, and what is your du? You integrate u with respect to x, then you get dx. Okay, it means that you have to integrate sine x dx. So this is easy because it will give you negative cos x dx. So the purpose of using this integration by parts is to reduce the multiplication of x cos x into another integral with a simpler form, which is much easier for you to integrate. Okay? If somehow by using the integration by parts, it gives you something like integrations for this part here, integration of v du, it gives you more complicated integral like integration of x squared, uh, let's say cos x dx. Cos x dx. Okay, if you compare with the original integral, this is x cos x. This one is cos squared which is you find this integral is much complicated than the original one. So you neglect the choice of u and dv. If it gives you something like this, if for, in our case it gives you much easier and simpler between integral. So this is fine. Okay, so it means that the answer is correct and it is doable to solve by using integration methods. Okay, if you get answer like this for the integration, then you move on to the next choice. Okay, it might give you the correct answer. Okay, okay. Then this is the strategy of using U and DV. Okay, logarithmic, inverse trigonometric, divide trigonometric exponential. Okay, but it is not always correct. Okay, so it is called what? LIATE. Okay, so like this one, in this case, we have x and ex. Okay, according to this order, so you have the exponent and you have what? You have the exponent and you have this is like algebraic. Okay, x is algebraic. Okay, so your choice will be u equal to x, not the other way around. Okay, because we follow this order. But it is not always correct. I'm sure of this. But you can try. You can try this order. Okay, but for me, I always try both choices. Okay, but you might try the one that follow this order. Okay, first before you continue uh, with the next choice. Okay. Okay, so this is the choice. U equal to x and dv equal to ex dx. Okay, so this one will give you what? In terms, by using integration by part, it will give you uv minus integration of v du. What is left is to decide what is your u. So if your choice is u equal to x and your dv equal to ex, then you have to integrate u with respect to x, if you dx. Okay, then you will have the integral. So v is equal to integration of v du. The v is this one. Your dv is this one. But if you integrate ex, you will get itself. So that's why ex is equal to, sorry, v is equal to ex. Okay, so this is your v. Okay, so here you have x. Your v is ex. Okay, integration of v, integration of ex, and du is dx. So it gives you a much easier um, integration compared to the original one. Okay, so you can continue and get the answer. Okay? You compare this integral here and this integral. This is much easier integral compared to this one. Okay? You might try what will happen if your choice is u equal to ex and your dv equal to x dx. Okay, so this one will give you du dx equal to ex. Okay, it means that your du is equal to ex dx. And then from here, you can decide that your v, you integrate both sides, it will give you x squared over 2. Okay. By using integration by parts, this integral here is u v minus integration of v du. So u here is ex multiplied with v, which is x squared uh, divided by 2 minus v, which is this one, x squared divided by 2, okay, and then du. So this is your du. Okay, so ex dx x. Okay, du is ex dx. So from here, if you look at this integral, it is much complicated than this integral. So we got this choice and try another one. Okay, so that is how we choose the choice of u as well as v. Okay, and then let's look at example 3. Evaluate integration of non-x dx. Okay, so you can choose. So this one, if you note, there's only one variable which is non-x, but you can create a new variable which is 1. Okay, which is 1. So your u is 1 and your dv is non-x dx. Okay, then you can continue and get the answer. It's not difficult. Okay, but then it could be that your integration needs repeated integration by parts in order to solve. In order to be solved. Okay, so let's look at example 4. If you have this integral here, x squared e to the power of negative x. Okay, so if you choose u equal to x squared, your dv will be another variable, which is e to the power of negative x dx. Okay, you integrate this, you get this one. The 2x, okay, dx, and then in order to get v, we can integrate this. Okay, and then we got this one. Okay, so then you substitute into integration by parts. uv minus integration of v du. Okay, so uv, you multiply this with this one. Okay, it's okay. Minus integration of v du. So this is your v. Negative e to the power of negative x. Okay. And what? And du. What is your du? It is 2x. dx. Okay. So if you look at this integral here, you still cannot solve this integral because it still involves multiplication of two variables, which is difficult for you to integrate. But if you look at the integrand of the integral, okay, this is of order 1, while this one involves of order 2. Okay, this is a variable of order 2, and this is of order 1. So by applying integration by parts once again, there's a hope that we can reduce this variable of order 1 so that it's only a constant to a constant. Okay, if this one is this part here is reduced to a constant, then we can easily integrate this part, this integration of v. So that is what we're gonna do. Okay, so okay, up to this part we have done. Okay, so the last integral is similar to the original, except but now we have, instead of x squared, we have x. Okay, then we apply once again, add on this. Okay, u is equal to x and dv equal to this one. Okay, and then once you apply uh, the integration by parts on this integral, okay, on this integral, then what we have is what is this one, this uh, this solution here. And then after you get this solution, then you substitute in this uh, expression here. Okay. If you look at here, negative x e to the power of negative x minus ex. Okay. So we substitute it here. Okay. Negative x squared e to the power of negative x plus 2. Okay. And then this one here is being replaced for this integral. Okay, so simplifying give us this answer. Okay, any questions? Anyone? Okay, the next one. Example 5. Evaluate integration of ex cos x dx. Okay, so your u is cos x. You can have two choices, but we follow the order. Okay, logarithmic, inverse, algebraic, trigonometric, and exponent. So you have here exponent as well as cos of x. Okay? The cos of x is trigonometric. Okay, so your u will be cos x. Okay, because it is before the exponent. It comes before exponent. So you apply u equal to cos x instead of ex. Okay, so dv is equal to ex dx. Okay, so du is negative sine x dx, and then for v, you integrate this one. Okay, and it gives you v equal to ex. Okay, and after that you substitute in this integration by parts formula and give ex cos x and then plus ex sin x. Okay, if you look at the new integral here, it is not reduced to a simpler looking integral. Okay? It doesn't even remove the, the trigonometric function. Okay, we still have sin x even though we don't see any cos x, okay, anymore. But then it gives us an idea that if we do the integration by parts again, once again, it might give us uh, the original one. Okay, so let's do it. Okay, so if you choose u equal to sin x, okay, dv equal to ex dx. Okay, in solving this integral here, in solving the integration in star, so you will get u equal to sin x, your dv is ex, and then it gives you this one, these two, okay, and then if you apply the integration by parts, okay, so this is the integration by parts, it then gives you, okay, so this is the key, it gives you the original integral, which is ex cos x, okay. So your idea is to combine these two integrals. So your ex, so this integral here, ex cos x, which is this one, is equal to ex cos x, okay, ex cos x, plus the expression that is given by this integral here, which is this one, which is this one, which is this one. So plus ex sin x minus this integral. You combine these two, you bring this integral to the left hand side, it will give you two integration of ex cos x dx. Okay? If you combine these two, it will be plus. A plus another A will give you 2A, right? Okay, it's the same here. This integral plus itself, it will give you two of this integral. Okay, so two of this integral is equal to the right hand side. If you want to get this integral here, you can divide the solution by 2. So this is the final answer. Okay, so any questions? Anyone want to ask any questions? No. Good. Okay, okay, now, let's look at um, so this is what the integration by parts for define it. So this is just the same idea, but this is for this define it. It means that the limit, the limit for the integration and the lower limits of the integrations uh, are constant. Okay, are constant. So it means that we can solve the integral, not just leave the answer you can solve. Okay, so so in order to solve this, you can try u equal to tan x, okay, and your dv is equal to dx. Your du is this one. You integrate arctangent of x, you get 1 over 1 plus x squared dx, and v is equal to x. Okay, then you can solve this. Uh, you can solve this. Okay, for uv, you can straight away minus u v when x is equal to 1 with uv with x when x is equal to 0. Okay, for this part here, you can integrate this one x divided by 1 plus x squared. So how are you going to solve this? Start from here. X 1 plus x squared is equal to this one. Okay, is equal to 1 half of 2x 1 plus x squared. Okay, and then it gives you this ln 1 plus x squared. This is by using substitutions. Substitutions. If you have u equal to so this part here, you can try with u is equal to 1 plus x squared. In order to solve integration of 2x 1 plus x squared dx. Okay? If you have u equal to 1 plus x squared, your du dx will be okay. So you substitute it here so that everything will be in terms of u. So integration of 2x, okay, 2x, you divide with you divide with 1 plus x squared, which is u, okay, and your dx is du divided by 2x. So this 2x is cancelled out. So what is left is integration of 1 over u du, which will give you ln of u. Okay, give you ln of u. And after that, you replace back to the original variable, which is in terms of x. It gives you ln of 1 plus x squared. Okay, so that's why you have this. So 1 half is because of this. It's because of that one. And then you can solve. And after that, you can simplify and solve and get this answer. Okay, so that's it. I think this is easy as well. But you can ask any questions if you have problem. Okay. Okay. Next one. Reduction formula. Reduction formula is for the trigonometric function for sine and cos. So for sine, let's say you have sine to the power of um, sine to the power of 12. x, dx, this is not something that you can solve easily, okay? But then you have this formula here so that you can reduce to another integral, which is sine n minus 2. So if in this case it is n equal to 5, then uh, the new integral will be sine n minus 2, which is 5 minus 2, give you 3. Okay, and after you get sine to the power of 3, you can reduce so that the new integral will be just sine x. By the time you get this one, you can easily solve this integral. Okay? Because this one is easy. Integration of sine x is just negative of cos x. Okay. So this is two important um, formula, your reduction formula. Whenever you have a higher order, okay, higher order of trigonometric function, sine and cosine. It's the same for uh, cos to the power of 3x. Okay, cos 3, cos to the power of 3. Okay, cos x to the power of 3. Integration of this. You can use this integral here so that this new integral here will be cos of x. Okay, integration of cos of x is easy for you to solve. Okay, as compared to the original one. Okay, I think I can love that one for you to solve. Okay, you might try example 8. Okay, example 8, cos to the power of 4 x dx. Okay, so which one that we want to use? Okay, which formula? I think it should be this one in equation 10. Okay, okay, with n equal to 4, you reduced it so that it is in terms of cos to the power of cos x to the power of 2. Once you get cos x to the power of 2, then you use this formula. Okay. Once you get this one, when you get this, what you do, this is just the same. Once you get this formula here, sorry, once you get this integral, you can get a new integral by applying equation or formula 10 once again. Once you apply it, you get 1/2 cos to the power of 0, it gives you 1. So that's why here a constant 1 stays. Because you have cos x to the power of 0. It gives you 1. Okay? Integration of 1 will give you x. Okay? X over 1. So this is the final answer. So you can apply this this formula for odd order as well as even. Okay, for n even as well as odd, for both even or odd. Okay, if it is odd, then it will give you integration of either cos x or sin x. Okay, for the n new integral, but if it is even, you will get integration of 1. Okay, I think that's all. Let's go to the next topic. Okay. Um, Integration trigonometric function. Okay. For the integration, integrating trigonometric function. Okay. Integrating powers of sine and cosine. This is another. This is the same this is the same formula as before. This is also equation, sorry, I think this is equation 9. So this is equation 9 and this is equation 10 from the uh, previous topic, okay? And then in this case, where n equal to 2, this formula leads you to these equations. Okay? If n is equal to 2, the new integral will be integration of a constant 1. Okay? Like I've mentioned before, because this is even. Okay? And this one as well. Integration of 1. Okay. So and then it says here that the phonetic form of this integration formula can be derived from the trigonometric identity. Sine squared x here is equal to 1 half 1 minus cos x, and cos squared x is equal to 1 half 1 plus cos 2x. I think we have seen this integral before. Okay. Sorry, this equation before. Which is also can be written as this integral cos 2x. If you make cos 2x as the subject, you can rearrange this equation here so that it can be written as 1 minus 2 sine squared, 2 sine squared x, and cos 2x is equal to 2 cos squared x minus 1. Okay, and then this identity here we'll start. It's from this one. It's from this part here. Okay, if you integrate this, it gives you 1 half integration of 1 minus cos 2x. Okay, and then what? And then it is 1 half 1 minus 1 over 4 sine 2x plus c. Okay, it's the same for this one. Okay, okay, so basically from the equation 9 and 10, which you can reduce the order of the trigonometric function. I think you can do the exercise and example at home. Okay? They are not so difficult for you. Okay, and then we have here the combination of two trigonometric functions. So let's say you have sine 4x cos to the power of 5x, okay? And here you have sine to the power of 4x cos to the power of 4x dx. Okay, so what is different here? So this one involve even, and this is involving odd. So this is for the combination, the product of two trigonometric functions. Okay, so this is even, and this is odd, and this is even, and this is odd. Okay, so there are different cases. For n, if your intervention is sine nx, cos nx, okay, it depends. If you have n odds, okay, you split off a factor of x. So this will be your procedure. If n odds, if your n odds, then this will be your procedure. Okay, and this is the identity that you have to use. Okay. And if n even and n even, then you have to use this procedure here, this process here. So for the first one, the n is even, n is odd. Okay, n is even, n is odd. So you use the first one. So this is for A, right? So this is n even and odd, and this one is n even and n even. Okay, so this for B, we use this one, n even and n even. So let's look at the solution for A. Okay, since n is odd, then we follow the first procedure, which is this one. Okay, so sine to the power of 4x cos to the power of 4x cos x. Okay, the first one, split of a factor of cos x. Okay, so first thing, you have to split this. One is cos to the power of 4x, another one is cos x. Okay, and then you have to use relevant identity, which is this one. So your cos to the power of 4x can be written as 1 minus sine square x, okay, because this is to the power of 4 and this is to the power of 2, you have to take to the power of 2, okay. So cos so cos uh, cos square x, okay, cos square x to the power of 2 is equal to cos to the power of 4x, okay. So cos square x is this one, 1 minus sine square x, okay? So that's why you have to the power of 2. Okay, and then you have cos x here, okay, dx, okay, and then you use substitution. Your substitution will be sine x, okay? You have to use substitution u equal to sine x. Okay, so your u is sine x, so this is u to the power of 4 minus multiply with 1 minus u squared, okay, then you have squared, okay, cos x cancel out in, in the process of changing from dx to du. So this part here will be cancelled out. Okay, so this is just power, okay, the power of u, which can be solved by using power, power rules, okay, power rules. Okay, and after you solve in terms of u, you can uh, substitute so that everything will be in terms of x. Okay. Okay. For B, we have to follow the third procedure here. The third case here. We use a relevant identity to reduce the power of sine x and cos x. Okay. So that's one. Sine squared x, and then you have squared, cos squared x, and then you have squared. And this is the identity that you have to consider. Okay. Then you substitute the identity. Okay. Then once you substitute the identity, this one you apply this rule. 1 minus a, 1 plus a, multiply with 1 plus a is equal to 1 minus a squared. So this is what you apply here. Okay. So this is your a. The whole thing is your a. Sorry, 1 minus a. So it means that this is your a, cos 2x. And 1 plus cos x. So a here is cos 2x. If you combine this, it will give you 1 minus cos squared 2x. Because a is cos 2x. So cos squared 2x. So 2 will stays. Okay, will stays because um, we don't involve with the power, okay, in this case, while multiplying, okay, it will stays here. And then you use this formula here, this formula, okay, 1 minus cos squared 2x, okay, so this is from identity. Sine, sine squared x plus cos squared x is equal to 1, okay, so cos squared x will be 1 minus sine squared x, okay, or cos squared 2x can also be written as 1 minus sine squared. So that's why we got here what? 1 minus this part here. 1 minus this part here will give you just sine squared to x. And then once you take the power of 2 into account, that it will give you sine to x to the power of 4. I hope it is clear. If it is not clear, then please let me know. Okay? Any questions? Is it clear? Okay? Do you understand what I'm teaching now? Okay, and after that, you can solve it. You can solve this integral here, and to the power of u to the power of 4. Okay, it means that I think this is not a correct way to write or to use substitutions. If you have sine, how do you get this? Sine to the power of 4 u du. Formula 13. Which one is 13? This one. Okay, they just use this formula. They just use this formula. 13. 1 over 32 sine 4x. Sine 4x plus 2. This one. They use formula 13. Okay, this is correct. Oh, this is okay as well. Okay. That's it. That's it. So easy. Just follow those in this table. Okay. When you have multiplication of two trigonometric functions, then you have to solve the integral by using this table. Before that, you have to decide uh, the the value for n as well as the value for m. M and n, is it odd or even? Then after that, you can use this table. Okay. It's the same for tangent and secant. Just the same. I hope you can do at home. Because we have here the same procedure, but it is in this table here. They are also concerning on whether m is even or n is and n or sorry m and n, is it even or odd? Okay, so if n even, then you have to use this procedure. If n odd, then there's one. If n even and n odd, then you have to use this procedure. Okay, so this identity here is just from the first identity. Okay, so the first identity is sine squared x plus cos squared x is equal to 1. Okay, but if you divide the whole thing at the left hand side with sine squared x, okay, then you will get 1 plus cos squared x divided by sine squared x equal to 1 over sine squared x is equal to 1. Is equal to cosec, right? Cosec. Cosec squared x. Okay? Cosecant. Cosecant squared x. 1 over sine is cosecant. 1 over cos is secant. Right. Okay, and this part here will be what? Will be sine x divided by cos x is tangent x. cos divided by sine will be a cot. So this will be cot squared. Okay, so we have 1 plus cot squared x equal to cosecant squared x. So this is one identity. Okay, one identity that is achieved by using the original identities, trigonometric identity. If you divide with cos, then you will have this identity here. Okay? If you divide with cos, you will get sine squared x divided by cos. It gives you tangent squared x plus cos squared x. You divide with cos squared, it gives you 1 equal to 1 over cos squared x. It gives you secant squared x. Okay, so that's why you get this. Secant squared x is equal to tangent squared x plus 1. Okay, and they're basically the same. They're basically the same identity. Okay, so this is the second one, and this is the third one. The first one is the original one, which is this one here. Okay. Yeah, I think we can do at home. They're just the same. We have to be hurry because we have like I think 1 or 2 top chapter before we finish our syllabus. Okay, and what is important is that this syllabus that we're gonna study will be asked in your final assessment. Okay? Your final assessment. And this week is the week 12. I think week 12. 12, right? Or is it 11? I think 12. Okay? Week 12. And we still have another 2 weeks before you face your final assessment. So let's move on. Okay, the methods of trigonometric substitutions. Okay, trigonometric substitution. We have this integration of square root of a squared minus x squared, square root of x squared plus a squared, square root of x squared minus a squared. Okay. If you have the radical in expression, integration of a squared minus x squared, then you have to use substitution x equal to a sine theta. Okay. If you have this, if you have the first one, then you have to use this one. Okay. And then okay, let's try. Okay, so this one here, it is in terms of square root of 4 minus x squared. So it means that your a here is equal to 2. So your a is equal to 2. It is suggested that you have to use x equal to a sine theta. So your a is equal to 2. So it gives you 2 sine theta. Okay, 2 sine theta. So your dx is 2 cos theta d theta. Okay, then you can apply substitution. They are just the same like before. Okay, but somehow here it can be cancelled out, right? It can be cancelled out, but this is of order 2 and this is of order 1. Okay, and then what? Square root of 4 minus 4 sine squared theta. You can simplify this. So it's from identity. Okay, so sine squared theta plus cos squared theta is equal to 1. Okay, so if you have 1 minus 1 minus sine squared theta is equal to cos squared theta. Okay. But then if you have 4 minus 4 sine squared theta, it means that you can factorize the 4. Okay, you can factorize 4. Okay. 4 square root of 4, and then 4 multiply with 1 minus sine squared theta. Okay, so this part here is equal to cos squared theta. Okay, square root of 4 cos squared theta. Okay, so it gives you what? Square root 2 cos theta. You square 4, you get 2, you square cos squared theta, you get cos theta. So what is left? What is the final solution for this is 2 cos theta. Okay. So from this one, you can cancel out this one. Okay, you cancel out this 2. Okay, what is left is sine squared theta. 1 over 4 is taken out from the integral because it's just a constant. 1 over sine squared is just cosecant. Cosecant squared theta. You integrate cosecant, you get cot theta. Okay? So this is from table. Okay? Integration of cosecant squared theta is equal to cot theta is from the table. Okay. Now, and now this is in terms of theta. The integration is of x, okay? The original integration is in terms of x, but then our solution is in terms of theta. So uh, you have to simplify this or change the theta so that we get in terms of x, okay? So here you have to use this triangle here. So this is our theta. From this, x is equal to 2 sine theta. It means that your sine theta is equal to x divided by 2. Sine theta is 2. So, opposite divided by hypotenuse. So, your opposite is x. Your hypotenuse is equal to 2. If you get hypotenuse and opposite, obviously you can get the adjacent using Pythagoras theorem. Okay, the adjacent by using the Pythagoras theorems, and this is what you get. Okay, now cot theta. Cot is uh cot is 1 over tangent. Okay, so cot is 1 over tangent. So if tangent for tangent theta, it is for the formula will be so O divided by A, right? Opposite divided by adjacent. Okay, so for cotangent, it will be the opposite of this. So for cotangent of x, it will be A divided by, cotangent of, this one should be theta. This one should be theta. It's not functioning. But it's fine. This one should be A divided by O. Your A will be this one. You divide this O, which is this one. So that's why you got this. Okay? Is it okay? Okay? I hope everyone can understand this. Okay? So for tangent, I repeat once again. Tangent theta is opposite divided by A from the formula that you always remember from your secondary school. You have so which is sine theta equal to opposite divided by h, hypotenuse. Tangent is 2r. Tangent is equal to opposite divided by adjacent, and then for cos theta is adjacent divided by hypotenuse. So tangent theta is O divided by A, TOA. TOA, TOA. So cot is 1 over tangent. So obviously it's just reciprocal of this, which is A divided by O. I cannot write it here. A divided by O. Okay. So A is your adjacent. Your adjacent is this one. You divide with O, which is this one, which is X. So that's why you get what theta is this one. So once you get in terms of, sorry, the expression in terms of X, you can replace it in this expression here. So that will be in terms of X, not left in terms of theta. Okay, we want it so that the solution is in terms of X instead of theta. So that is how you change from the variable theta to variable X, depending on your triangle. Okay. Okay, next one. Okay, so this is just definite integral. I think you can I can skip this one because we have repeated many times about definite. Okay, for this definite integrals, this is I cannot write. I think I have to. I think let's close this. I cannot even close it. I cannot even go to any page. Yeah, I don't know how. So this is the only page that I can see. Are you still with me? Can I get any feedback or is it already hang? Okay. Can someone reply to my WhatsApp so that I can get a feedback from you? Whether you are still with me or my computer, which is already hang here, doesn't allow you to be with me. Anyone? Okay, can
Yes,
you? Okay, I got a feedback. So you are still with me, so I can continue. I cannot write on the screen. Okay, by the way, this is definite. So what you have to do here is this finite limit, okay, the limit of the integral is in terms of x, because the integration is with respect to x, right? So in order to substitute the limits while solving this integral, you have to make sure that you already change everything to the variable x, okay? Like this one. You cannot substitute x equal to 1 and x equal to square root of 2 in this equation, in this expression, because this is theta, not x. So you can substitute x equal to 1 and square root of 2 when you get the final answer, which is in terms of x, okay? So that is how you have to be careful with that. Or if you want to stop it here, okay, for the definite integral, if you want to stop it here, you have to change the limit so that it is in terms of theta instead of x. So how do you change? Of course, by using these substitutions. You already know the x, you want the limit so that it is in terms of you have to use these expressions. Okay? Okay, like this one. X is equal to 1. So this is your substitution. X equal to 2 sine theta. X equal to 1 and x equal to square root of 2. Your theta will be a sine of 1/2. Okay? From this substitution equation. A sine of 1/2 or a sine of square root of 2 divided by 2. Okay? It gives you pi over 6 and pi over 4. And once you get these two values, this is your limit for theta. So it means that you can substitute it up here. And you don't have to use this triangle, okay, in getting writing the solution in terms of x. Okay, like this one. Okay, you don't have to use this triangle so that you can get the answer in terms of x. You can stop it here, and after that you substitute the limit, because your limit is also in terms of theta, okay, instead of x. Okay. Okay. Now let's look at this table here. We have went through the first cases here. I've mentioned before, if you have a square root of a squared minus x squared, then the substitution that you have to use is x equal to a sine theta. But then what if your integration is involving a squared plus a squared? Instead of a squared minus x squared, it is a squared plus a x squared. Or it could be that integration of x squared minus a squared. So for these two cases, the substitution will be this one, x equal to a tangent theta, or x equal to a tangent theta, and x equal to a secant theta. Okay, and I think you can do at home. But then let's look at this integral. So this is square root of 1 plus x squared. So your a is 1. Okay, and then it involves plus. If you look at this, the substitution that you have to use is x equal to tangent theta. Okay. X is equal to tangent theta. So x squared will be tangent squared theta. Okay. So that is how you solve the integral. Okay. What about this one? This is integration of x squared minus a squared. Okay. X squared minus a squared. You can use this substitution. X will be a secant theta. Okay. So a secant theta. So your a is 5, then x will be 5 secant theta. Okay. Okay, and then you can solve this question at home, but we can go through the solution here. Okay, let's see this expression, which is the solution: 5 tangent theta minus 5 theta plus c. So okay, so for this one here, we cannot start at this solution because it is in terms of theta instead of x. Okay, we want to have the final solution in terms of x, so we have to use the triangle. Okay, so your substitution is x equal to 5 secant theta. Okay, I still cannot write. Okay, but then if you make secant theta be the subject, then you will have what? You will have secant theta equal to x divided by 5. So secant is 1 over cos. Okay, 1 over cos. Cos is adjacent divided by hypotenuse. Okay, so for secant it will be hypotenuse divided by adjacent. Hypotenuse divided by adjacent. Hypotenuse divided by adjacent. So x divided by 5. X divided by 5, and this one here, opposite, is obtained by using Pythagoras theorem. Okay? And then for tangent, because the solution is in terms of tangent, your tangent is 1, opposite divided by adjacent. Opposite is this one divided by adjacent, which is equal to 5. So that's why you got this one. Okay, so and then you substitute it here. 5 tangent theta 5 of this one, okay, minus 5 theta. So 5 theta, it means that the theta will be tangent of this, okay, 5 theta, tangent of this, right? Another way is, what is your theta? Sorry, here 5 theta, 5 theta tangent is this one, square root of, okay, 5 cancel out, okay, here 5 cancel out, minus 5 secant. Why is it secant? Tangent is 5 theta. Okay, they get from here instead of this one. Both is correct. If you use this substitution, then it will give you theta equal to secant of 5 divided by 5. So, sorry, secant, sorry, theta is equal to secant of x divided by 5, which is what is given here. Okay, but instead of that, you can also use this expression, which is theta is equal to tangent of this. Both is correct, but this is simpler. So let's just stick with this one, and then you plus with C. Okay. Any questions? Okay, I have to restart my computer. I will enter the meeting room, okay, in 5 minutes. Okay. So let's have like 5 minutes break, okay, before we continue our class. Okay. I have to start my class. Okay, by the way, your test will be next week, right? On on Thursday. On Thursday, the time will be from 1 to 2:30. Okay, your test will be on Thursday. Okay, next week from 1 to 2:30. Okay, uh, and the topic will cover everything related to different sessions except for graphing. Okay, so it means that the topic before the graphing. The graphing already covered for in in our quiz. Okay. Okay, next let's continue with the next topic, which is integrating rational function by partial fraction. Okay, so this is also a very important topic. Okay, partial fractions. Okay, so if you look at partial fractions, uh, like this one, 5x minus 10 divided by x squared minus 3x minus 4. Okay, so this partial fraction here is not, you, if the questions ask you these partial fractions, it is not easy for you to integrate. But this one here, this partial fractions here, is just the same as this, the the fraction on the left hand side, which is 2 divided by x minus 4 plus 3 divided by x plus 1. Okay, so if you have if you know these expressions, it will be much easier for you to integrate. But of course, you have to segregate into two parts. So the first is this integral plus this integral. Okay, but then these two back to the original integral. So the original integral is much complicated for you to solve. Okay, so our purpose in studying integrating rational function by partial fractions is to reduce this complicated looking partial fractions. So that we can reduce uh, partial fractions to a simpler looking partial fraction, okay, which is easier for you to integrate. Okay, okay. So if you have this integral, you can actually equate to this integral here plus this integral, and this two integral is just 2 ln x minus 4 and plus 3 ln x plus 1. If you are not sure of this, you can apply substitution method, which is u equal to x minus 4. And for this one here, u equal to x plus 1. It will give you the same answer. Okay, okay, so the procedure in solving partial fractions is denoting, let's say you have these partial fractions, okay, uh, denoting the numerator as a, okay, divide by this one, x minus 4, plus b divided by x plus 1, okay. Now we are up to find the value for a and b, okay. So you multiply both sides, okay, uh, both sides with this one, okay, with the denominator, you will get 5x minus 10 equal to ax plus 1 plus b multiply with x minus 4. Okay, once you got this, you can let x equal to negative 1. Okay, if x equal to negative 1, this one will cancel out, right? Okay, so negative 5 minus 10 equal to a multiply with 0 plus b multiply with -1 minus 4, -5. Okay, so a0, 0, -5, -15 here is equal to -5b. So your b will be 3. So your b will be 3. Okay, for a, you can in order to get a, you can let x so that it is equal to 4. If you let x equal to 4, this side will be 0. This side will be 0. 4 minus 4 will give you 0. So it will give you the solution for A. So I'm sure you will get 2. Okay, so for the value of A. Okay, so for this partial fraction, it reduced to this two simpler looking rational or partial fractions, okay, rational numbers, rational expressions, okay, or partial fractions. Okay, it's easier for you to interpret. Okay, so that one is when you have easy and linear, what we call it here, linear factor of partial fractions. Okay? But what if you have this is for linear as well. Okay, so if you factorize this, you get x minus 1, x plus 1. Both are linear. For both linear, it's just the coefficient is just a and b. Okay, so it is easy for you to solve. Okay, because they are both linear. You don't have here like x minus 1 squared. You don't have here x plus 2 and then squared. Okay. So for linear, it is easy for you. The coefficient is just a and b. Okay. But what happens if your factor is not linear, like this one? If you factorize, then it will give you x squared multiply with x minus 2. This is not linear. This is quadratic. Okay. So if you so this expression here can also be written as, let's say this is star, okay, 2x plus 4. I'm too lazy to write down the numerator, but this is x minus 0 squared multiply with x minus 2. Okay. So this is star. Okay, so this is star. But then this is not linear like before. So how do we solve for the partial fractions involving something which is not linear? Okay, okay, so for this one, for uh for this one here, since it is quadratic, you have to write down a divided by x plus b divided by x squared. So there are two coefficients here. One is a, another one is b. For to tackle this part, x squared. Okay, for this part here, x minus 2, it is okay. So it's just c divided by x minus 2. Okay, so for the third part, it is okay. But for x squared, you have to segregate into two parts. One is a divided by x, another one is b divided by x squared. Okay, and then you can simplify this. in order to get the value for A, B, and C. Okay, it's not difficult for you to do, but it may, if you don't do a lot of exercises, then you may have problems like mistake here, okay, in getting the value for A, B, and C. Okay, and then here you have what? Okay, so that one is x squared. So that one is you have x squared and then multiply with x minus 2. X minus 2. The next one is we have here x squared plus 1. And 3x minus 1. So x squared plus 1, 3x minus 1. So this is okay. This part is okay. This part is okay. What is not okay is this one. Okay, we have to manipulate this part here. This is okay because the coefficient is just a divided by 2x minus 1. Because it's just linear, but this is not. Okay, so for this part here, x squared plus 1, it will be bx plus c divided by x squared plus 1. Okay, so you have the coefficient bx plus c because of this x squared. So let's say you have the denominator x squared plus 1 squared multiplied with 3x minus 1. So this part is okay. The coefficient will be a divided by 2x minus 1. But for this one, okay, here you have x squared plus 1. And then this is also not linear, okay? So for this part here, it will be bx plus c divided by x squared plus 1. Alright, okay, wait. If you have this, wait a minute. So if you have bx plus c, x squared plus 1. Okay, x squared plus 1. Okay, this is correct. And another one will be dx plus e divided by x squared plus 1 squared. Okay, plus 1 squared. From the previous procedure. You have here a divided by x plus b divided by x squared. Okay, we have here x squared, so that's why you have bx plus c divided by x squared plus 1, okay, plus dx plus c, okay, so the thing with x plus c, bx plus c or dx plus e is because of this, x squared plus 1, okay, but the squared here needs you to segregate. One is x squared plus 1, another one is x squared plus 1 squared. Okay? And then, so that is in case you have this kind of, expression. But our integral is much simpler than that. It's just this one, x squared plus 1. So the expression is bx plus divided by x squared plus 1. So this, for the 3x minus 1, the coefficient is just a, as it is linear. Any questions? And after that, of course, you have to simplify in order to get A, B, and C. You might as well use simultaneous equations. Simultaneous equations in solving the equations. Okay, any questions? Is it okay? One to 2:30. I have class at 2 p.m. So actually the duration is just 1 hour. It's from 1 to 2. But then I give you extra 30 minutes in case you have problem with the internet connections. So if it should be enough to do it in 1 hour. But then if you still need time, then you have to rearrange the time. Like maybe 12:30 is it okay? 12:30 to 2. What about, I'm talking about our test, okay? I'm talking about our test now. Since some of you are not free at 2 because you have class on Thursday, okay? What about if we make it 12:30, okay? So yeah, I think we will decide the time later, later through WhatsApp, because some of you might miss this information. But I hope everyone know that the test and our final assessment is just around the corner. It means that you have to study harder than before. Okay. 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 That is when you have the partial fractions with the numerator. Here, the order of the numerator is lower than the order of denominator. So this is the order of 2. The order is of 2, and this is order 3. Okay. But then if your order of numerator is higher than denominator, then you have to do long division. You have to do long division before you can apply uh, the procedure that you have learned just now. Okay. Okay. So that kind of rational function is called improper. Improper rational function. Like in this example 5, the numerator is of order 4, but then the denominator is of order 2. Okay, so you have to do long division. Okay, you have to do the long division so that you can get proper rational function. Okay, so this is called this is called proper rational function because the numerator, the order of numerator is lower than the order of the denominator. Okay, so once you got the proper rational function, you can then apply the procedure that we have just learned before. Okay, in order to get A and B and so on. And after that, you can easily integrate. The end purpose is to integrate. Okay, we want to integrate this solution, this integrand, so that it is easy for us to integrate. Okay, we want to reduce this integrand so that it is easy for us to integrate. But then we notice that this is improper integral. Because it is improper, then you have to do long division. Okay, once you do the long division, okay, then you can apply the procedure before, okay, like this one, x squared plus x minus 2. So what you have to do here is obviously factorize. This part here is just power rule. If you integrate, it's just power rule, right? Power rules. But this part here, you have to factorize. Okay, what will be the expressions? X, this is x, this is 2, this is 1, plus minus. So this is what you will get. If you got this, your coefficient will be what? Will be a divided by x minus 1. So this is just linear. So that's why your coefficient is just a. Plus, this is also linear, divided by plus b divided by x plus 2. So after it reach here, obviously you can apply, you can find the value for A and B, okay? And the final answer will be this one. This is combination of ln x minus 1, ln x plus 2. Ln can be combined if it is, let's say you have ln x minus 1 divided by x plus 2, it is actually equal to ln x minus 1 minus ln x plus 2. Okay? If it is plus, so this is equal ln x minus 1, okay, this is x plus 2 is actually equal to ln x minus 1 plus ln x plus 2. Okay, so if you see something like this, don't be too afraid of it. It's just minus, so it means that our ways of solving it is correct. Okay, so this part here is, if you integrate, it will give you ln of x minus 1, and this part here will give you ln x plus 2. Okay, and somehow you combine it so that it is in terms of this. Okay, I think that's all about integrating of partial fractions. Okay, integrating partial fractions. Do you want to proceed our last chapter today or next week? Our last chapter will be, I think 2 weeks is enough to cover our last chapter. Our last chapter could be infinite limits. So this is our last chapter. Okay. Okay, let's continue or let's stop. Which one is better? Okay, I think let's start our class today. For today, okay, let's start it now. We will continue our last chapter next week. Okay, I hope we will finish it soon. But then please study for your test. Okay, so thank you very much for attending my class. Yes.
Excuse me, doctor. Sorry to interrupt. Doctor,
Who's
for the
talking
test
actually?
for coming
Can I know?
Thursday.
Who's talking?
Sorry? I'm Surya, doctor. Sorry,
Okay.
doctor. For the coming Thursday, doctor, for the test, the link will be given on that day, right?
The link will be given as soon as possible. I will create the link as soon as possible. Once I'm free, okay, I will create the link, but then I activate the link just before, like 5 minutes before the time.
All right, doctor.
Is it
Okay.
clear?
Okay, doctor. Thank you. Yes,
Okay,
clear,
I
doctor.
will
Thank you.
try to give you the link as soon as possible. Okay, once I finish creating the quiz, the test in Google Form. Okay, once I finish creating the test, then I will straight away give you the link through WhatsApp, as well as my guru. I always put the link to my guru as well. Okay.
Okay, doctor. Thank you so much,
Any
doctor.
other questions? Okay, good. Thank you for being with me. Okay, let's stop it now. Thank you very much.
Thank you, Doctor.
Thanks.
Thank you, Doctor.